everyone, and welcome to the CP-31 Sheet Solutions by TLE Eliminators. This is Vibhaas Srivastava, and today we'll be discussing the 1600 rated problem 31, Kuroni and Impossible Calculation. Okay, so let's just head over to the CP-31 sheet. Let's open up this problem and let's read the statement and see what it's about. All right. The problem states, to become the king of Codeforces, Kuroni has to solve the following problem. He is given n numbers, a1, a2 till an. Help Kuroni calculate the product of, for every pair I less than j, right, ai minus aj mod. So product of this ai minus aj mod for every pair where I less than j. As the result can be very big, output it modulo m. Okay, so they have explained what the product notation means. Basically means a1 minus a2 mod times a2 minus a3 mod times so on, then a2 minus a3 mod. Basically pairwise, for every element, every pair which we can form, we need to take the absolute difference and multiply it together. All right, so it's the product of absolute difference between two elements for all possible pairs which we can find. Okay, what are the constraints? n goes up to 2 times 10 power 5, m goes up to 1000, the integers go up to 10 power 9. And what we have to output? We have to output the single number which is ai minus aj mod m. Okay, so the problem itself is very straightforward. There is not much to explain about what the statement is asking. Let's just mention the expected time complexity, right? Expected time complexity. And since n goes up to 10 power 5, you would expect something like, let's say we go of n log n. M most probably, m is weird here because usually modulos go up to 10 power 9, right? Here modulo m goes up to 1000. So you could think of some solution which is like maybe big O of like m square log n, or maybe big O of n plus m square, something like that. These could also be possible solutions or possible type complexities of what we are searching for, right? And it's always good to know what we're looking for in the very start of the question. So we're looking for some kind of solution like this. Okay. What else do we need to pay attention to? We need to pay attention that an goes up to 10 power 9. So obviously, unless you have like log of ai, it won't contribute to our time complexity, right? And we need to output the single number which is the product of ai minus aj mod m. Okay, so now to solve this problem, you mostly need a very keen eye, right? There is not much data structures algorithms going in here. You need a keen eye and you need mathematics. Most probably you already know the mathematics required, but you just need the keen eye to spot it. Okay, let's get into how to solve this. Okay, so let's get into intuitions. All right, so now I can see why most people would be led astray, because right now, for example, we're given n and m. Let n be 15, let n be 15, let m be 10, right? Let n be 15, m be 10, and then we have some elements like 5, 4, 3, 1, 2, 6, 7, 8, 9, 10, right? How many elements is that? 5, yeah. Then we can have maybe 21, 22, 23, 24, 25. As you can see, we have 15 elements now. And now basically what we need to do is we need to compute this product, right? We need to compute the product, which is like ai minus aj for all the pairs I and j. So that's going to look something like this, right? So our answer is going to be basically 5 minus 4 times 5 minus 3 times 5 minus 1 and so on, right? This all multiplied together. Then we need to multiply like 4 minus 3, 4 minus 1, so on, right? And we get some answer like this, right? So you would think that the solution would involve some kind of maybe finding the answers from this to everyone. Then based on this, maybe we could do some kind of DP when we go each step, one step forwards or something like that, right? And these are the ideas generally which come to your mind first when looking at these kinds of problems. But that intuition is not quite correct, because if you try and see, we'll struggle to find a DP, right? Because the value after multiplication is not like is not directly easily calculatable. Like, it's not, if we know the value over here, it's not easy to know the value over here by some kind of DP. All right. Okay. So then what should we do here? Okay, what should we do here? That's the question. And so here there is a very interesting observation which comes into play, which I will just write down. And the observation is, so this will come to you if you're keeping your, if you're thinking out of the box, and if you keep your mind open to what all mathematical facts you know. So the observation is, and obviously this is a good strategy, like when you're doing things modulo something, you should always make it simplified, right? You should make it simplified. So the observation is basically, if you want to find the product of, let's say, I comma j, um like what was the product? It was 1 less than equal to I less than j less than equal to n, right? And ai minus aj, right? If you were trying to find this product, basically this would be the same as um finding the product of, yeah, you want to find this product, and once you find this product, you want to do mod m, right? You want to do mod m. So we can simplify this by using the rules of modulo, right? We can simplify this using the rules of modulo. Basically, if we want a times b mod m, right? How do we write this? We write it as a mod m times b mod m, right? So you would know this if you know basic number theory regarding modulo. This is pretty commonly known for, I think, 1600 level problems, so I won't explain it too much. And if you reach 1600 level problems, you should know this fact. Yeah. So what we're going to simplify it as, we're going to write product of ai minus aj mod m. Okay, so we're going to take products of modulo, and then we're going to have mod m in here as well, right? So we distributed the mod m inside the products as well. So that's what we did over here. Okay, so that's what we did over here. Now, one more thing we can do is we can distribute inside this absolute difference as well. And the simple reason for that is, either the absolute difference, either this absolute difference, it's equal to two things, right? It's equal to ai minus aj, or it's equal to aj minus ai. In both cases, if we were to take mod m, then we can use simply the subtraction property over here. Like mod m distributes over subtraction as well, right? So if we have a let's say minus b mod m, we can write it as a mod m minus b mod m, right? Mod m, right? So we can write it like this, as long as it doesn't become negative. But in this case, since it's absolute value, it's never going to become negative anyways, so we can distribute it inside, right? It's never going to become negative anyways, since it's an absolute value symbol, so we can distribute it inside, right? I hope that's clear. So we can write this as, basically product of a of I mod m minus a of j mod m, right? Where we distributed inside the absolute value mod m, and then this whole thing, once we have done, we will do mod m again, right? Okay, so basically each number in our product can be treated as being taken modulo m. Okay, each number can be treated as modulo m, right? So let me succinctly write down this observation. So let me write down our observations so far. And basically our first observation was mod distributes inside multiplication as well as absolute value difference, right? Absolute value difference. So that much is fine, we understood. So based on this, we reached the conclusion that each a of I can be treated as a of I mod m. Okay. All right. So we have noted this down. Next, we need another observation. So this has almost like, take a pause over here. Okay. Take a pause and see what we did and see if you can solve the question now completely by yourself, because now I think you have enough information to see how you can do that. Okay. So pause right here and see if you can do it. All right. If you cannot do it, here's another hint, and you can pause after that as well. Now we had this test case, right? 15, 10, and these numbers 5, 4, 3, 1, 2, etc., etc. You can take, we know that we can treat these values mod m, right? So take mod 10 of all these numbers and see how does that affect the answer. Okay. Okay. So let's say we take mod 10 of all these values. So I'm going to do that right now for the example, right? So 5 mod 10. So all these values we're taking mod 10. Okay. So take mod 10 for all these values because we showed that that will not change the answer. So we have 5 over here, 4, 3, 1, 2, 6, 7, 8, 9. These will not change. This will be 0. This will be 1, 2, 3, 4, 5. Okay. It will be 1, 2, 3, 4, 5. Now the interesting thing over here is, okay, the interesting thing over here is, here we have a 5, right? Here we have mod 10 equals 5. Here also we have an element 5, right? So if we take the products of the differences over here, at some point we will get the term 5 minus 5 absolute difference, right? And basically it will be something like 5 minus 4 times 5 minus 3 times so on, and we'll get 5 minus 5 and then times something else, right? And this value is 0, right? This value is 0. So basically, if two values are the same with respect to mod, our answer becomes 0, right? So we can write this down as well, and this will simplify a problem a lot. So if ai percent the mod, right? So ai with the modulo is equal to aj with the modulo, right? That means basically we're multiplying to the product ai minus aj, which are both the same with the mod. So basically the product becomes 0, right? So basically then we can write 1 less than I less than j less than n equal to 0. Okay, so this is our second observation, that if ever two elements have the same value with the mod, our answer is going to be 0. Okay, and pretty much if you make a check for this, this would be enough to solve the problem. But there is another thing which you need to show, and that's simple. Okay, and that's simple. Since m goes up to 1000 only, right? Pay attention. In the question we mentioned earlier that m goes up to 1000, so that could maybe be some clue. And yes, that is indeed a very big clue for this question. Since m is at most 1000, right? Or actually, yeah, since m is at most 1000, if n gets larger than m, right? So if n is larger than m, what happens? At least what happens to the values of a1 mod m, a2 mod m, a3 mod m, so on till an mod m, right? But n is larger than m. So let's say this was a unique mod, this was also a unique mod, and this was also a unique mod m. But then eventually something has to get repeated, right? Some value of mod will end up getting repeated because m is smaller than n, right? And the number of modulo values we can have is 0, 1, 2, 3 up to m minus 1, right? These are the possible modulo values with respect to m. But if n is larger than m, that means more than one repeated by the pigeonhole principle, right? So you need to know some basic pigeonhole principle for this. um you don't need to know the name, you just need to know the idea that if you put an excess amount of things in less amount of things, um obviously there'll be some repetition, right? There'll be some repetition over here. So we can say that, formally, if you want to write it formally, we'll have to use pigeonhole principle. So we can say that, um the values a of I mod m have at most m possible values, right? Since n is greater than m, by pigeonhole principle, by pigeon, not exactly sure the spelling, by pigeonhole principle, at least um two values a of I mod m is equal to a of j mod m, right? Two values will overlap, correct? So that means whenever n is greater than m, whenever n is greater than m, by property 3, which says that two overlapping values make it 0, when n is greater than m, the answer will be 0. Okay, the answer will be 0 simply if n is greater than m. And now this is more than enough to solve the problem. So first thing which we observed was mod distributes inspired multiplication. Second thing which we observed was if two values are same with respect to the mod, the answer is 0. Now we are noticing that n greater than m means that the answer will be 0. Now also we need to keep in mind that m is at most 1000. So basically we can do this. Okay, we can do this following solution. So here let me just write solution. um solution solution if n is greater than m, answer is 0, else um n will be less than m, right? So n is going to be less than m, um which is less than equal to 1000, right? So n will be less than equal to 1000 in this case. So what we can do is, since n equals 1000, we can just find the answer in big O of n squared, right? Find the answer in big O of n squared, right? So that's all for our solution. Which will big O of n square, or since n goes at most till m, so big O of m square, right? That's all for the solution to this problem. We can write it down. The code for this is pretty straightforward implementation, right? The time complexity for this we can say is big O of n plus m square, I guess, or you can just write big O of m square. But yeah, to be completely formal, it would be written as big O of n plus m square. All right, this is the type complexity, and the memory complexity here would be simply big O of n, right? Because you're just storing the values once and calculating the product with respect to mod. Be careful while calculating the product with respect to mod. Make sure that you take mod at each step, otherwise you might overflow in the middle, right? You might overflow in the middle, which is definitely possible. So if you pay attention to those things, like don't overflow or use long. Pretty straightforward to implement this. Okay, so I don't think there's any confusion in knowing the solution, but I can see that you would be frustrated to arrive at this. And for that, I have this advice. If you find this problem a bit tricky, um, practice number theory, obviously. So these ideas, like modulo, etc., should be at the top of your mind. And the second thing is think outside the box, right? These kinds of questions are more like think outside the box sometimes, if other things don't work, right? So this is not exactly a standard any algorithm or something like that. No Euclidean distance algorithm would help you solve this. So yeah, it's slightly thinking outside the box and always simplifying with always simplify mod by distributing inside. You can say that it's a lesson in that as well. Okay, let's have a look at the code. Okay, right? The time complexity is big O of n plus m square, because obviously we have to read the n values, right? Okay. So we take in n and m, we take in our vector a. If n is greater than m, we can simply output 0 and return. There's not multiple test cases, so that's why we're just directly returning over here. We're returning from the program. Otherwise, we set our answer as 1, right? This is going to be the final answer, which is the product of all aj minus ai. For each I and for each j greater than I, we're going to multiply the answer. Make sure that here I'm multiplying the absolute difference mod m, right? Because obviously that doesn't change the answer, and also it won't overflow. Here answer can overflow and give you a wrong answer, right? And then multiply answer with the mod, obviously. And once this loop is done, we can print the answer. So this is for the n greater than m, and this is for the m less than equal to n. N less than equal to m, which means n will be less than equal to 1000, right? So it obviously passes under the given time complexity, right? Okay. So that's about it for this problem. Kuroni and Impossible question. And with this, Kuroni can become the king of Codeforces. So yeah.